Hi, we are engineering brothers. In our previous class, we have explained the complex roots of our upper portion over there and how do I get the CT versus time plot over there. I have already explained over here. I want to replace or I want to represent that in front of you once again to give you the best form of analogy over here. First, just by looking at this S plane, we have considered our much needed S plot over there, and after using the much needed formulation of our A square minus B square formulation we are having, this is our going to be the formulation over there. And in our next step we have considered that the system do have the input of impulse response over here. That is why the RS will be 1. And if you just do put the RS is equal to 1, we are having CS is equal to this one. And at the last stage, if you just do apply the inverse Laplace on this given CS format, we are having the time domain equation over here, which is this one. And if we do plot this as our given plot over here, which is CT versus time, we have analyzed that this is going to be our given plot over there, and after that we have analyzed that the waveform do have the tendency to go to the zero value over there, and that actually give us the characteristic of a stable system over there. And in this class we are just going to explain the lower portion or the complex roots of our this plot. We are going to explain that over here. So to explain that, first we are going to analyze the S plane over here, or what seems to be the pole location for our S plane plot over here. So we should have started from that one over here. Now at the first stage we are having our plots over here, which is this one will be our j omega axis and this one will be our sigma, and these are our two plots over here. Quite naturally we can say that at this point we are having our two poles that are placed over here, and we say this one will be our sigma and this one will be our plus j omega and this one will be our minus j omega over here. Now what are the plots or plotting points over here? Let us just write down over here S is equal to sigma plus minus of j omega over here. So the first plot will be quite naturally S1, which is sigma plus of j omega. Now sigma plus j omega will be these pole plots over there, and sigma minus of j omega, that will be considered as our S2. That will be sigma minus of j omega. That one should be these lower points over there. Now these are our quite naturally the complex roots over here, and quite naturally these are our complex consideration over here, and we can say that what seems to be the transfer function, or how do we form the transfer function over here. Let us just utilize that one over here. First of all, we are having our two plotting points over there. Now what is the value for our transfer function for this overall system? The transfer function for our overall system will be this one, which is quite naturally Cs divided by Rs, and we are having our constant of A that will be present at our numerator portion, and in our denominator portion we are just going to consider the much needed pole plots or pole positions over here, which are S minus sigma minus of j omega. This will be our first one, and the next one would be S minus of sigma plus of j omega. Okay, now what is the overall transfer function in this case? We do know that the same procedure over here. We have identified the S plots over here, and how do we consider the two pole plots over there that I have shown you over there. Now if you just do transfer this sigma and j omega to the another side of our expression, we are having the multiplication of our two denominator factor over here. Now if you what is the exact procedure to have the pole plots over there? If you just do make this multiplication that will be equal to 0. We are having these two individual plots over here, and we have plotted that in our S-plane over here. Now quite naturally this will be our exact transfer function that we are trying to focus over here. Now let us just solve that over here, and how to solve or how to get solved to these given equations over there, that will be the much important consideration over here. According to our formulation, we do know that a square minus b square, that will be quite naturally a plus b into a minus b, and here you can say that this one is our a and this one will be our b. We are having a plus b, a minus b format over here, and in this case the a will be quite naturally s minus of sigma over here, and the b will be quite naturally our g omega. Now at this place of our s square minus b square, we should put that over here. Now just by putting that value, we are having s minus sigma square, this one will be minus of g omega squared. Now if you just do further simplify our given consideration, we do know that the j is equal to root of minus 1 over here, and to have the j square value, we are having j square is equal to minus 1. Okay, now let us just put that over here, and quite naturally the exact expression will be s minus sigma square, and this one will be plus omega squared. Okay, now at this place we are just going to consider that over here. Now a divided by our s minus sigma squared plus of omega squared. This will be our consideration over here, and how do I get to that considered points over there? I have already explained that in our given consideration. Now I am just going to erase over here, as we have already explained that on how to get to that considered time domain analogy over here. Now ultimately we are having our given waveform, that is Cs by Rs, that is quite naturally our Cs by Rs, that will be this one. Okay, and in our next stage we are having considered that the Rs will be 1. Why? Because we have taken that the input for our given system will be impulse consideration or impulse input over here. Now for that one we are having the Rs is equal to 1, and if you just do put that over here, we are having Cs is equal to quite naturally our A divided by our s minus sigma squared plus omega squared over here. Now this is our going to be our Cs over here after we have considered the Rs is equal to 1. And what is the Rs? We have taken the input for our given system. Our input for a given transfer function will be our impulse input over here, and I have considered that over here at the considered point. Now Cs will be A divided by this factor over here. Now Cs will be this one. Now at the last stage, if you just do apply the inverse Laplace on this given equation or in this given form, if you just do apply the inverse Laplace on this given equation, we will get back to the time domain equation, which is Ct. The Ct will be quite naturally A, and the formulation seems to be our A is e to the power sigma t of our sine of omega t. This will be our formulation for our considered time domain analogy over here. And how do I get to our considered point over here? I'm just going to explain over here once again. First, we are having our S-plane for our pole location, or according to our pole location, we have considered our S-plane over here. And just by looking at this S-plane consideration, we do require to form the much needed transfer function over here that we have shown you all the steps in a step by step over here. And at the last stage we are having Cs is equal to 1, and how do I consider that? We have taken that the input for our given system will be impulse input over here, and just by considering that in our given format we are having Cs is equal to this one. Now at the last stage, if you just do apply the inverse Laplace on this Cs equation, we are having the Ct, and this is going to be our inverse Laplace form. If you just do apply the inverse Laplace on this given format, and we are having this will be our city over here. Now in our plotting case, if you just do like to plot that in our given waveform, which is city versus time over here, and the equation will be this one, which is city is equal to this one over here. And if we do plot that in our city versus time curve over here, we have realized that the waveform do have started from 0, and if you just do increase the time, which is the time t tends to infinity, for that one the oscillation is increasing. You can see that the oscillation is increasing with respect to time over there, and that do give us the characteristic of our unstable system over there. Why? Because there is no possibility to have the finite value over here, as the oscillation is increasing with respect to time over here. That is why we can comment, or we can say that the state system will be unstable over here. Why? Because the oscillation is increasing with respect to time. Now if you just do say the time t tends to infinity, that has got the huge amount of oscillation over there, and that is the characteristic for our nonlinear system, the unstable system over here. Okay, and we can explain, or we can say another part for our consideration. As you can see that the pole are placed at the right hand side of our S-plane, then we can say that quite naturally or automatically the system is unstable over here. Why? Because we can comment that, or we can consider that according to our location of our poles, we can say that what is the exact status of our system, whether that system is stable or unstable over here. As we can see that the poles are located at the right hand side of our S-plane, we can say that this system will be unstable. Okay, we can explain the unstable characteristic just by plotting the waveform of CT versus time over here. We can explain that just by looking at our S-plane over here. That is the exact way to consider our stability consideration over here. I hope you have totally understood up to this one. If you still have any doubts, please let us know in the comment section. For better understanding, do like, do share our videos, and keep following our channel. In our next classes, we should consider many other options or many other considerations for our locations of our poles. And at the last stage, we are going to explain what is the exact statement for our stability for that said system over there. Just wait for my next classes. That's it. Thank you and goodbye. If you like my video, so what are you waiting for? Please do subscribe my channel, hit the bell icon for more updates, and stay tuned to the channel. Thank you and goodbye.